If I want to find out the nth term of this number pattern, I simply look for the gaps between the numbers. So from 2 to 7 is 5, 7 to 12 is 5, 12 to 17 is 5, and so on. This tells me that it's going to be 5n plus or minus something, and I can easily work out that it's 5n minus 3. Every time the first differences are the same, the nth term will look something like this. Now this question tells me that I've got a quadratic sequence. That tells me that when I find the first differences, they're not going to be the same. Here I've got 3, then 7, and then 11. But when I find the second differences, they will be the same. I've got 4 and 4. Whenever I have this situation, I have a quadratic sequence, and the nth term will always look something like this: an squared plus bn plus c. All that I have to do now is find out what a, b, and c are. To do this, I'm going to say that for the first term, n equals 1. I'm going to work out what that would be in terms of a, b, and c. So I've got 1 squared times a, that's 1a, so that's a. 1 times b, that's 1b, so that's b. And c on its own. Now I'm going to find the second term. So when n is 2, I've got 2 squared, that's 4 times a. 2 times b, so that's 2b. And again, I've just got c. And I'm going to find the third term as well. So when n is 3, I've got 3 squared, that's 9 times a. Plus 3 times b, so that's plus 3b. And again, I've got plus c on the end. Now I can find the first differences between these. So from this to this, I can see that I've increased by 3a and by 1b. From this to this, I can see I've increased by 5a and 1b. Now I can find the second difference. From this to this, I can see that there's been an increase of 2a. I can now look at and compare the two diagonals highlighted here. Starting at the bottom, I can see that 2a must be equal to 4, so that tells me that a is 2. For the middle one, I know that 3a plus b must be equal to 3. I already know that a is 2, so 3a is 6, so I've got 6 plus b equals 3, and that tells me that b is negative 3. Finally, I've got a plus b plus c, and that must equal 0. I know a is 2. I know that b is minus 3. I don't know what c is yet, but I do know it equals 0. 2 minus 3 is minus 1, so c must be 1 to make 0. Substituting these three values into this gives me 2n squared minus 3n plus 1, and this is the nth term of my quadratic sequence. It's always nice to double check your answer. What I'm going to do is check the third term of the sequence. So remember here, n equals 3. So I've got 2 times 3 squared minus 3 times 3 plus 1, and I'm hoping that this is going to give me 10. 2 times 3 squared is 2 times 9, so that's 18. Minus 3 times 3 is 9, plus 1. Now 18 minus 9 plus 1 does give me 10, so I know that my quadratic sequence has this as its nth term. Now, because this seems quite complicated when you're first starting out, we're going to work through this question together a bit at a time. The first thing I'd like you to do is find the differences and then the differences of the differences. Press pause and do this. When you're ready, press play. This is what you should have so far. Now remember, the nth term will be in the form an squared plus bn plus c. Now we want to find the first three terms algebraically. To do this, I want you to replace n with 1 then with 2, and then with 3, and write down your 3 answers. Press pause and have a go at this. When you're ready, press play. And you should have got this. Now I'd like you to find the first and second differences. Remember, you're doing this algebraically. Press pause and have a go. When you're ready, press play. You should have this. We're now going to compare the two diagonals, starting from the bottom. So we have 2a equals 6, 3a plus b equals 11, and a plus b plus c equals 5. I'd now like you to solve these 3 equations to find the values of a, b and c. Press pause and have a go. When you're ready, press play. You should have that a equals 3, b equals 2 and c equals 0. To finish off, I'd like you to substitute these 3 values into this equation here to get the nth term for the quadratic sequence. Press pause and do this. When you're ready, press play. And voila! You've now found the nth term of the quadratic sequence. Here's one for you to try on your own. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you. Press pause and have a go. When you're ready, press play. Here's the answer. Now, sometimes you get this sort of question in a context like this, and it makes it look much more difficult. The trick is to notice that they're only asking for the number of cubes in the bottom layer of each tower. Be really careful when you're working out the number for Tower 3 and Tower 4. You'll then be able to do Part B using the techniques that we've looked at in this clip. Press pause and have a go. When you're ready, press play. Here are the answers. To help me get these 2 numbers, I've drawn out the bottom layer of each tower as a 2D representation. I've had to flip the tower round a bit, but it helps you see the pattern.